Well, let's keep moving along. In chapter section 10-5, recursion and iteration. We're now at page 693. We're going to take a look at writing recursive formulas. Now, in order to write a recursive formula, we're going to be given some data. Either we're going to be given a sequence itself, or we're going to see here just a little bit later on, we're given some factors that may help us determine what the sequence may be, or back into the sequence, if you will. But this first example we're looking at here, we're given a sequence. It's 8, 20, 50, 125, 312.5. We're being asked to write a recursive formula for this sequence. Now, first thing we've got to do is determine, is this an arithmetic sequence? Is this a geometric sequence? Is it some kind of combination of the two? Just exactly what is it? And in order to do that, I'm looking to try to determine, can I see a pattern in this sequence that gives me a common difference or a common ratio, or as we're going to see a little bit later, possibly both. So I'm looking at this sequence, 8. Oh yeah, the last thing I got to do once I determine what the formula is going to be, in order to express it properly, I've always got to give a value for A1. That initial term is going to be given for a recursive formula, and we are writing recursive formulas. So I've got a sequence. I got 8, 20, 50, 125, 312.5. Okay, let's see. So if I'm looking to see if I can determine a common difference, well, 20 minus 8 is 12. But 20 plus 12 does not give me 50. In fact, it gives me 32. So I'm initially ruling out that there's a common difference. What about a common ratio? Well, if I take 20 and divide it by 8, let's see, 20 divided by 8, what does that equal? That's going to equal 2.5. And how about if I take 50 and divide it by 20? Well, I get the same thing, 2.5. And I think if I just take a gander at that, it looks like that I've got a common ratio of 2.5. And I believe that would hold true. If I take 50 and multiply it by 2.5, I get 125. And I'm going to go ahead and do this. 125 times 2.5 does in fact give me 312.5. So shazam, there I go. I found a common ratio. And so I can write my recursive formula like this. I got AN equals 2.5, the common ratio, A. And where A1, first number in the sequence, well, I know what that is. It's right there. Equals 8. All right, not too bad. Pretty simple. Look to see if I can find a common difference. If I can't, then look to see if I can find a common ratio. We're going to see a little bit later on. We've got to try to figure out both. But these first couple are not too bad. And in this sequence, AN equals 2.5A. Oh, I should put AN minus 1. So I'm going to be totally correct. AN equals 2.5A n minus 1, where A1 is equal to 8. Okay, so once again, we're asked to write a recursive formula for a sequence. And I've got a sequence here of 8, 17, 26, 35, and 44. And as you may recall, I first want to see if can I find a common difference. If I can't find a common difference, am I able to determine a common ratio? If I can't do that, then I'm probably looking at some kind of combination that gets a little bit more complicated. But let's look at this sequence. 8, 17, 26, 35, 44. All right, so 17 less 8 is 9. And 9 plus 17 is 26. It's looking good. 26 plus 9 is 35. And 35 plus 9 is 44. So I must have a common difference of 9. And I don't see any other unusual thing about this, so let's write this recursive formula. I got AN equals a n minus 1 plus 9. Remember now, I've got to identify what a1 is in the sequence, where a1 equals 8. All right. More fun to come. Here we found the common difference, and we were able to simply write a recursive formula. Wish they were all this simple. Okay, so here we're still writing a recursive formula, and we're asked to write a recursive formula for the sequence, but we're going to twist in this one. We're not actually given the sequence. We're given what the third term in the sequence is, and we're even told what the common ratio is. And, well, we're pretty well home right there. So I could start like this. I could say an equals 4 common ratio times a to the n minus 1. And that's actually my recursive formula. But one thing I got to remember, I've got to identify what a1 is. So now if a3 is 16 and the common ratio is 4, how do I find a1? Well, let's see, if I divide 16 by 4, that would give me a2, correct? Well, 16 divided by 4 is 4. So a2, if I want to get to a1, I can take a2 and divide it by 4. And 4 divided by 4 is 1. And so how about this? a1 equals 1. Okay, that one's not too bad. The next one I'm going to look at got a little bit more complexity to it. Stay tuned. Okay, so those first two that we looked at, where we first tried to find the common difference, find the common ratio, we found our common ratio, we found a common difference, wasn't too bad, we wrote the formula. And then when I scan through what your homework problems look like, there's not a single one of those is as simple as what I have just done. And every one of them has got greater complexity than that. And even then, some of the homework problems that you're going to do are even going to be more complex than what I'm looking at right here, but I do at least want to go over this with you. Now, this is actually problem 5 in the textbook, in the where I would ordinarily assign homework. It's on page 695. Problem 5, it's a problem for example 2, which is what we're doing, writing a recursive formula. So let's at least look at this. You're going to put your thinking caps on to wade through this homework, and I bet we're going to end up working some of them in class because there'll be some confusion. But hey, that's how we learn. We get confused and we learn. Let's look at this sequence here. So I got 3, 8, 18, 38, 78. All right, I'm going to first say, okay, do I have a common difference? Well, the difference between 8 and 3 is 5, but 8 plus 5 is 13, not 18. So I don't really have a common difference. If I take 8 and divide it by 3, I think that's going to be 2.667 or 2 2/3. But if I take 18, and because I'm trying to find a common ratio, by the way, in case you're wondering what I'm doing. If I take 18 and divide it by 8, I've got 2 1/4, not 2 2/3. So I don't have a common difference, and I don't have a common ratio. So I've got some kind of combination of both. So let's think about what is the pattern here. All right, so I've already established I don't have a common difference. I don't have a common ratio. So let's see, what's 3 times 2? Well, 3 times 2 is 6. And 6 plus 2 is 8. All right, well, what if I take 8 and multiply it by 2? Well, 8 times 2 is 16, plus 2 is 18. I'm beginning to see a pattern here that this is 2a n minus 1 plus 2. Let's go ahead and test that out further through the rest of the sequence. 18 times 2 is 36. Well, 36 plus 2 is 38. Okay. I'm not sure I can do 38 plus 2 in my head. At least I don't want to. 38 times 2 is 76, and 76 plus 2 is 78. Shazam, I have found the recursive formula, and I can write it such. AN equals 2A n minus 1 plus 2, where A1 is equal to 3. All right, there we go. I see a combination there of the common difference and the common ratio. Have at your homework problems. They're going to be fun. You're going to have to think your way through these. This ought to be a homework assignment I ought to grade. In fact, I'm glad I'm recording this. I think I will grade it. That ought to be fun. See you later.